Hello, everyone, and thank you for joining us for today's session. My name is Askia, and I'm one of the event planners for the Redmond Reactor space. And before we get started today, I've got a few things I'd like to go over. So if you could just take a moment and read our code of conduct. Basically, what that is saying is that we seek to provide a respectful environment for both our audience and presenters. We definitely encourage engagement in the chat, but we ask that you please be mindful of your commentary, try to remain professional, and if possible, please try to remain on topic. We're going to be sharing useful links throughout the chat, so please keep an eye out for that. And we want to let you know that this session is going to be recorded and will be available in about 24 to 48 hours on the Microsoft Reactor YouTube channel. And that brings us to today's session, scheduled to run approximately 60 minutes, and there'll be time for questions throughout. So with that said, I'd like to hand it over to our speaker for introductions.
Yes. Hi, everyone. Thanks so much, Saskia, for having me here. I'm super excited. Yet another session at the MS Reactor. This session is going to be quite interesting and relevant to the people, developers, decision makers, and technology evangelists who are building AI applications. Because from my experience, also, I found like AI applications need to handle, oftentimes data securely, to serve more clients. In our cases, like if you're talking about the Microsoft Azure cloud, it should serve multiple tenants. In my talk today, I'm going to introduce a simple and powerful solution, how you can do data isolation for your RAG applications using a simple solution, a database-per-tenant model for vector-based AI applications. And I'm going to show you full stack, also example of RAG app built with modern technologies, including like OpenAI or React.js, Microsoft Azure resources, and Neon serverless Postgres in my demo. So yeah, my name is Babur. I'm founding CTO at Datadog. I do also a lot of development work, the different like the projects, including the Neon one and ex-Microsoft, also Microsoft MVP for AI platform. So before diving into the details of how we can do a multi-tenant RAG, the approach, let's have a look what is a RAG pipeline looks like for a single user. Because it's always better when you learn new things to make a step back and then analyze the basics, and it will make more foundation for you to understand the more advanced topics. As you can see, this is a typical diagram how the RAG pipelines looks like. As we all do, like at the first stage, is more about preparing and indexing information that we want to be used in our application. It's, as you can see in the diagram, from step 1 to 4. And what we do, we load and extract text from some documents. We split these documents into chunks so that each chunk ideally small, like a single topic or maybe one sentence, or if it's an image, like one portion of the image data. We use then embedding model from LLM providers to turn each chunk into the vector representation. And we store these embeddings into vector storages, or we call it a vector database. If you're using vector database approach, there are other approaches available nowadays, like a graph RAG, or even you can do some keyword search. In my case, I'm using vector search for my RAG pipeline. And we store every chunks into this vector storage, and that brings ourselves to the second stage, dealing with upcoming questions. Think about like you're building Copilot chat that retrieves some information exists in the vector database. In the steps from 5 to 10, in the second part of the diagram, whenever question comes in, we are generating embeddings from it. Just like we are identifying to retrieve most relevant chunks from the vector storage. And we can apply like, hey, when you're fetching, just get top 3 or top 5 from the finding relevant match. and we are always comparing the actual text of the query against the text of the each chunk coming from vector database. And finally, we are building a prompt to send a generative AI chat model like chat completions. The model of your choice with a boss question, and then top n chunks we found from vector storage. And then we return friendly response back to the user. This is like the RAG pipeline. I think some of you already aware of how the things work. There are other advanced like the RAG pipelines you can build up, or you can build a more custom solution. But then the main topic is for today, identifying the issues in these RAG pipelines for multiple users or multiple tenants. In our case, when I say tenant, is a company or the business entity or the group of people as a tenant representing a set of people. As you can see, when the RAG pipeline is used inside a multiple user environment, usually RAG application it can introduce noisy neighbor problem, because RAG applications are heavily rely on data inputs, like as we have seen before, vector database and external API calls like LLM models, or using external tools. As a result, we can see a noisy neighbor problem coming up at two levels for multi-tenant or RAG applications. One is in the database level, where one usage of one organization or one tenant amount of data can impact the overall performance of the application. While one organization usage is very low, at the same time another organization using a lot of data, and as a result, organization A is having the performance issues. And the RAG execution level, for example, spike in usage, for example, like LLM models calling, API calling, can introduce a rate limiting, which obviously slows down and blocks other users' RAG executions. If you think about we're using one RAG for multiple people, multiple users, customers, or how you can call the tenants. This is like the big issues for RAG pipelines. Now, what we want to achieve is every organization or every tenant usage shouldn't affect on the usage of, first of all, LLM costs of another tenant. For example, if organization A is less using LLM, but they are still paying with the same price, it can also lead some sort of miscalculation of LLM costs. Also, one organization shouldn't be accessed to another organization data, as for golden rule for typical SaaS applications. And you should have a separate database or vector in idle solutions. There are multiple, of course, SaaS solutions, how you can separate this isolation in the application layer or in database layer, even in database schema layer, or doing some sharding mechanism and so on. But today I'm going to introduce more the concept of multi-tenancy for isolating data for each organization to make sure that we are guaranteed the capacity for every user or every organization. And this helps us to achieve one usage of the RAG pipeline that shouldn't impact the capacity of others. But the question is how. In the answer here, again, we can always keep the same application, run one application instance, but separate for database for each persona. So it means rather than having all vector embeddings or vectors the data stored in a single Postgres database or single vector database. In my example, I'm using Postgres database with let's say some PG vector extensions, where Postgres allows you to store some vector embeddings, which is like nowadays we have seen changes, like instead of using multiple databases, one for vector storage, another for operations, another for analytics, it's always preferable to use one database, and then you can have all data in one place to make sure that you are easily managing everything in one place. But now you have providing each tenant or user organization or workspace, or we can call entity, with its own dedicated Postgres instance, where you can store and query embeddings separately. So user B cannot have access to the user A's database. Depending on your application, you can always provision vector database after specific event happened. For example, when the user sign up, we can spin up new database, or when new organization created on Azure, we can spin up again then as database, or something like happened in the pricing tiers, like upgrade to paid or upgrade to enterprise pricing plan. You will then track each tenant and their associated vector databases in your application as a main database. Like you can always have one application layer. So, and how we can achieve these in terms of like more using the modern Postgres solution. In my case, I'm introducing Neon here. One thing is it brings, like as you can see in the slide, Neon completely introduced new model of approach for Postgres, especially for SaaS use cases. It creates a project for each customer. It is almost like a logical equivalent of instance without any operational difficulties, like all operational handed over by the cloud solution. So, which means each customer lives in their own project. As you can see, customer one has own project, and everything from provisioning to recovery it can be API driven. So as some event happens, you can always create a new project for each customer, and then you will get for each customer separate compute and storage. It means like customers' data is now completely isolated, and each project supports also additional branching. It's a lower hierarchy that allows you can create a multiple future branch. As you're creating branch for your Git, you can create a branch for your data, and you can have some dev and test environments for each customer. So what are the benefits if we are following the project approach offered by the Neon or similar like modern SaaS solutions? Instead of first of all like learning how to handle the large Postgres databases, is model that helps us to create new project when user joins something or any action happens quickly. So the API, that's we call it like more serverless and then API driven. And nowadays, and AI agents also can do the same now, as they are managing infrastructures. They can create the databases or when some event happens. And also each Neon project can be deployed in specific regions. For example, you can deploy in West or East US regions, making also easy to host customer data to closer their location. For example, one customer has one project hosted in West US and another one in East US. So also most important, I really like this per customer point in time restore that Neon has feature. You can easily restore any branch and the earlier state and then recover from that time. For example, I had the data for customer a year ago. I can just store more than 1 terabyte of data quickly in 1 second to achieve like point in time restore in case something went wrong with this approach. So, and for example, in this case, like if you have one vector database or Postgres solution per tenant in our rack solution, vector databases are, in my case, can be provisioned within the project when user signs up. As you can see this diagram, the prompt is coming about like the document, let's say 500 of pages of PDF, and then user asks like, what the document is about. And then at the same time, Neon creates a new Postgres solution and then and returns connection string for the user because the user already signed up and then asking the first prompt. and a user gets dedicated like a Postgres solution as a response, and again the application can connect. And we can also always do against the same vector storage, some similarity search, and then retrieve all the information to answer this prompt. I can show you one application I built as an example. This one is solution also we are going to export today. And this sort of like similar like Copilot chat, I would call it. But it's fully isolated in this case. It has some like features, as you can see. You can create some custom personas, prompts, API extensions. You can connect to APIs. You can upload documents, and even like you can interact with your voice and videos. Ask anything about like a chat. So you're using ChatGPT from the external provider. But the only difference is this application is actually hosted in Microsoft Azure and using all the Microsoft Azure resources to achieve this chat. And the funny part of it, like when you signed in, now I'm working in my isolated project in the database instance. Let's now break down some of the main features and technologies I used in this project, and then we can dive into more demo part of this application, how I build in the Azure using technologies. The key features here, as I mentioned already, I'm giving one database per user. You can, and then every time user signs in or actually signs up, it will get the database, and then each time signs in, it's gonna use the same database. And next is like we have the authentication, which is like you can authenticate the users using their Google accounts or GitHub or using Azure eventID to make sure that you have like a basic authentication also in place using login and password. This also supported in this application. And also you can upload any sort of documents, also commands on with voice and so on. Let me show you the actual diagram of this high-level diagram of this application hosted on Azure. As you can see, I'm using multiple Azure resources here. In my case, first I'm using for authenticating users Microsoft Enter ID, and my application is actually hosted on Azure App Service. That provides some REST APIs and backend services to connect and then get the users the queries, and then respond find the relevant information from the documents or from the videos or images. I'm also using Azure Document Intelligence service that maybe some of you already know. It automates data extraction from uploaded documents. It uses usually AI and like OCRs to extract images inside the documents and all sort of like content. You have unstructured content. At the same time, I'm using Azure Speech Service. Probably is not here is highlighted to convert speech to text or vice versa in my application. Plus, there are multiple services like Azure Monitoring Service and to monitor the actual application status, and the blob storage, obviously, to whenever documents are uploaded, to store files and images inside the blob storage. And therefore, to make the application more secure, when the application app service connecting to multiple services, I'm using Azure Key Vault. In some services, I'm using Entra ID, like system identity, to make sure without connection strings are connecting. But for example, especially for Neon or Postgres, I am keeping the connection strings inside the Key Vault. And the REST application almost like using system identity way of passwordless connection. Let's start to explore this application together with you. I'm gonna share my screen in a moment, but you can always explore the demo of the application, which is live on now online. you can also now go ahead and create your user and then play with application. But just by scanning this QR code, it will bring you to the application. The link is shared in the screen is more about the source code. But if you scan the demo one, it will bring you demo. Now, let me show you the demo first, and then we can dive into the details of the application, how I built this. Let me change my screen in a moment, then we can go with the demo. Just a moment. And I can change my screen. Here we go. And we are here. So I have now the screen will bring up. Yeah. This is the repo, host repo for multi-user RAG application. And then the demo itself is located in this link. The QR code should bring you to this application. What's happening here, if I now, let's say, show from the login page, now I enabled only GitHub way to authorize, but there is also in the solution, actually you can enable Google one or Microsoft Entry ID one. To make it simple, I just enabled the GitHub one. The funny thing is, when your first time is trying to log in or signing up, it will quickly provision the Postgres database for you. Now I have already signed up. Now I'm using existing one, and then you can try different functions, typical chat experience you can get, upload some documents or ask question, something like simple question or starting complex questions. Under the hood, actually I'm not using AI search tools. Yeah, this is typical the response you get when you're using LLM models and not properly. But the idea is here more about how this data is separated in the user level. That's the topic of today. We can have a look. Let me go into the repo itself to explain you more how the application works. So, and I also here provide in the report all the details. You can also try it out or deploy to your own cloud. And so it serves as a solution accelerator, using different Microsoft Azure services and tools. I'm using Node.js and also NextJS to build my full stack web application. There's also another library, NextJS, to make sure that my users are authenticating using this framework. And OpenAI SDK to connect to Azure OpenAI tool, and then some designing tools, libraries using in my application. So there are multiple options. You can even run the application locally if you have already hosted all necessary basic services on Azure, like the services we need, for example, Neon, Postgres, or you enabled any identity provider, GitHub or local one. For local one, even you can, it's optional. You can run without any identity provider. And here you can find some steps how we can run it locally. Otherwise, there are easier options using Azure Developer CLI, ESD commands. You can use it to deploy with the automated scripts your application quickly, or you can use one-click deployment to deploy directly from Azure portal using the biceps template. And the other steps, after deployment, what you should follow. First of all, you need to get the API key from the database, and some API keys needs to be updated automatically for you. And some consideration of what kind of costs expected when you're running this application. It should be super cheap. For me, almost cheap, except I'm using OpenAI service to pay. But other service like a form recognizer or app service, I'm using almost the free planning. But in here is I mentioned it like just the which pricing model is good for the production environment and so on. So let me go into my VS Code and show the my application, the main like parts you can just consider. First of all, when you're clone this application, you can see this structure of the code. There are some data docs and infra to automate my deployment with biceps, and main like application course source code is under source folder. And if we start with authentication part, it's under like auth page, auth API Typescript file. What's happening here, as you can see, I'm using multiple identity providers. Here you can see separate for development, like except for development, I can use a username and password just to make it simple. Otherwise, in a production environment, I'm using Azure Identity Provider and GitHub Identity Provider, and then there should be also a Google one, not in this branch. So what's happening here, whenever, let's say, user signs in, the magic part is happening here. I am creating per registered user new Neon project. So if you navigate the Neon project like a function, as you can see, I am calling the programmatically the Neon API to provision a new project if it doesn't exist already. If it exists, just we need to fetch a connection string from a project. Neon API has like a very good documentation. You can have a look and try to automate things with even like the JavaScript code. There is also a library we have for Neon management called the Neon database serverless, and just the SDK. You can reusable SDK to build the similar application. In this case, as you can see, if the Neon project doesn't exist, we are creating actually a new project and then returning also the connection string back to the user, and then mapping for each user ID new connection string. Also, we are initializing some database schemas to make sure the application is working with the initial tables setup. So what schema is we are enabling here is using vector extension, and we are enabling vector extension to store vector embeddings. And I have some tables here, like a chat threads, stations, personas, extensions, to make the application fully functioning. And some user asks the prompts, I'm storing as well. And the part here with the vector type, as you can see, for prompts, I'm storing also embeddings value of the prompt. Also for chat documents, every chat documents, vectorize it, and then it's stored inside the embeddings vector type. So this is like the part of how we initializing database. And the next interesting part is how we are doing a vector search operation. Usually, the Azure users use Azure AI search. You can always combine also with AI search to make more like hybrid search functionality. But now the Postgres also models, as they have Elasticsearch experience you can get by having both hybrid and the vector search. I'm using here two types of search, just a simple search and the vector search. Based on the request, it dynamically changes from simple search to the vector search. For example, here in simple search, we are taking, for example, search text from the user, and we are just finding with typical SQL query the matching for the text. This is a very straightforward one, but when it comes to similarity search, which is vectors, you know the concept of the RAGs. We are calculating vector embeddings from the OpenAI for the search text from the user, And then the magic part is here, how we are comparing vector embeddings against the embeddings of the document, which is fancy, the operator from SQL operator. This does all the magic, like to vector comparison. You can also define multiple 2 or 3 different algorithms for it. For Postgres, you can read more about like PG extension, PG vector extension. Here, I'm using just default algorithm to find the match vector, similar matching. So, and then like the same way we are returning found page content and chat thread and metadata and so on. This is like a typical basic part of the application you can define. And then like this is more about the application part. Then we have also got infrastructure part. In the infrastructure part, we are not obviously creating separate resources, Postgres resources on Azure, but you have one Postgres resource is created under the hood. We're creating multiple projects. Just this is a concept. Sometimes people confuse because when you're using a Postgres solution, existing like a Azure Postgres or SQL Server, you should create a separate instance. But in the Neon part, we're creating just a virtual memory, virtual projects instead of instance, which makes the cost is very low, because I can create multiple projects or multiple database branches, or even every user or developer of this application can get one branch and they can work on a future branch. Whenever the application migration is ready, they can just merge the main branch, which makes all the data changes, schema changes up to date for the main branch. So the biceps one, you have always options, like you can use, of course, next level like Terraform to automate this script, but I basically write down some biceps automation to spin up all my resources needed in this application. You can find also the code here. You can use as an example of it when you're deploying your application. And there is also Azure Dev Containers, of course, if you want to run inside the Dev Containers the same application. Therefore, Neon, we support also running the Neon in the local environment. It's called Neon Local. You can still run a Docker to the same Postgres, open source Postgres, but it will create like a proxy to the cloud solution, to cloud Azure solution. So let me switch back to my slides. I think this is about like the main part of the demo, the application I built. If I go ahead and then change my slides, just a moment. Changing my screen. There we go. Yeah, this is source code scanner. I think you have all the link. But in the summary of this talk, what I want to introduce here, let's say, what are the problems we are solving just by making the separate database for each user here. Whenever one customer like Spike and uses RAG now, doesn't affect like global application performance. Now, think about like application can be also horizontally scaled, because Azure App Series can have multiple like scaling options. But the idea of we are isolating in data level, which is still like good for SaaS solutions or sort of RAG solutions. Similar idea can be also replicated for AI agents. Like think about now, every AI agent has a separate database, like a typical microservices, and microservices says like each microservice should be responsible only for single task, and microservices have a data isolation, which means have a separate database. So agents also, we're pushing this concept forward I like the idea when the agents can have specific roles. Based on the roles, they can control the data they are allowed to, and then in this way they can provide more accurate data as output. And there are other cool RAC code samples you can find, and the same on the repo for Neon Database Labs. We are playing around with different, the applications. There are multi-agent Azure AI usage also. I demonstrated how multi-agents are collaborating with each other with a shared database or separate database. I recommend also if you can visit the multi-agent Azure solution hosted on Neon. And there are also other RAG application example built by me also on these repos. Now I can stop here, and then we can start to check if there are any questions from the audience, and we can address these questions. Thank you. Yeah, Fram, hi, thanks for the invite. Yeah, let's discuss someone asking if I can go and speak online. Yeah, I'm always open. We can discuss. I can send you my proposals, and we can decide on the dates. Yeah, if there is other questions, feel free to ask. About the SaaS solution and yeah, thank you, Fran. I think, yeah, if there is no other questions, we can wrap it up, make it short. If you have other questions, I will be more than happy to address. You can always scan this QR code and connect me on LinkedIn. I'm available also on X. So we can also, if you have any RAC application use cases, I'm more than happy to, dive into details and understand the use case, and maybe consult if I can help with some other searching operations, because most of the organization now having issue is either supporting multiple users or building more optimized RAC retrieval solutions for their use cases. I think we can conclude here. Thanks again for attending my session.